Welcome back. Today we are putting NumPy and native Python list in head-to-head speed test. We'll compare the performance for a numerical task, and by the end you will know exactly when to switch from plain lists to NumPy arrays, especially for big data like imaging processing and scientific computation. So we are going to run 3 common tasks: summoning, multiplying, and element-wise operations using both Python, lists, and NumPy arrays. We'll measure how long each one takes with thousands and millions of elements. First of all, we need to go to the terminal, and we are going to, first of all, clear and pip install NumPy. Whenever we've got our NumPy, we need import time, and then we need to import NumPy as NP. Then we need to create some kind of data size, and it will be equal to 10 millions, for example. And we'll have like file list. It will be list with range of n. That will be the first one, and NumPy array, and it will be np.array from n. So we are using like 10 million elements to simulate large scale data. So this is where performance really matter. And I just misspelled it. Then we need to create like using Python lists. Start will be time.time. Then we need NumPy equals some file list. Then we need and time.time, and we need print Python list sum, and we'll pass and minus start seconds. Also, we'll have start NumPy time.time, sum np will be np.sum. Here we need to pass our array. Then we'll have and NumPy time.time. We need to print NumPy list sum and minus start seconds, and run that. And I see my problem over here, NumPy, and start NumPy. And as you can see, already NumPy shows a big performance edge, like 10 times faster NumPy arrays, then we've got the Python lists. So we can just comment it out. I will just delete it. And then we are going to have something more advanced. So we'll have start equals. Maybe I will just copy and paste. It will be faster for you and for me. Copy and paste. We can go it like that, and we need by multiply. It's quite faster, easier to just create f times 2 or x in file list. And Python list multiplication, and that's the first one. Then we've got our NumPy multiplication, and how we just created np array times 2. Run that code, and as you can see, there's even quite bigger difference than we've got before. Previously, we've got like time 10s faster whenever we are talking about the NumPy. Now we are getting like 20 times faster. Because with NumPy, we avoid Python loops. Everything runs in compiled code. And as you can see, it's very, very huge difference. But whenever we've got something over here, we can check about the memory efficiency and some kind of summary of how they are faster. Print, for example, will have Python list size. And here we are going to len of Python list. And we need to Python list 0. That size of, yeah, it's over here with bytes. But whenever we're talking about NumPy array size, we need NumPy array, and to have the same things, we need n bytes, and we need to provide bytes. NumPy array, it's written like that, working. And as you can see, that not only NumPy is faster, it's also much more memory efficient. That's a double win for high performance computing. So should you ditch Python lists? Not necessarily. But when you're working with large numerical data, NumPy is a game changer. Faster, smaller, cleaner code. Hit like if this helps you, subscribe for more Python deep dives, and check the next video